Hi, Jocelyn. You can give us heads up in the chat section when you see us live in the stage. Hello, everyone. Just give us a hint if you see us on stage in the chat box. Okay, thanks, Jocelyn. Good evening, everyone joining from India, and good morning, good afternoon, good evening for everyone who is joining from across the globe. Thank you for joining us on Saturday on yet another episode or session of Tribecast webinar. We have done a lot of these before as well. We have a very special guest today. Before that, if any one of you is new to the test drive, this is a community which started out of India, based out of India, and then we have been doing pretty cool stuff virtually. Thanks to COVID, like few good things are also happening virtually, and we are able to connect a lot of global testers together. So we did Tribal Conf conference and TestFlix recently, which was a great success. Hope you all liked it if you have seen it. And I'll just drop a quick link in case you are not in the community yet, so that we can stay connected even after the event. You can see that in the chat box now. So we have Robert Sabourin today. I hope I was close, Rob. But yeah, what he prefers and what I prefer as well is Rob Fab. So he's famous by that nickname, and that's very easy and something which you cannot forget easily. I'm speaking to Rob probably fourth time now, and all the three times I have spoken to him before, I was blown away by the knowledge he has, by the experience he has, and you will realize that when he gives the introduction about himself. But he has 38 years of experience in software space, and he has been into several roles. The kind of things he has done, the tools he has developed, the things he have tested, and again the work as an author and everything else, that is phenomenal. So it's our pleasure having you here, Rob, and
Thank you.
I'll now hand it over to you. You can just quickly check if you are able to start your screen share.
Okay,
And for
just a
the
sec.
audience, so the format, the usual format, which is around 45 minutes of the webinar session, and then we'll reserve 10 to 15 minutes for Q&A. But yeah, Rob can adjust the way it suits him while he starts. Let me just quickly see if the live stream is going on. Yeah, on YouTube it looks fine.
Sorry, can you see my shared screen?
Yeah, Rob, I can see that.
All right. So
Okay.
shall we start?
Yep. So thanks again, Rob, and stage is all yours. I'll go
It's
off video, but yeah, I'm available in the chat
okay.
section.
Thank you so much, Mahesh, and thank you everybody for hanging out with me. I'm in Montreal, Canada right now. To give you some sort of context, when I wander outside, it's hovering around 15 to 20 below 0 Celsius, and it's quite early in the morning, so everybody else is sleeping, which usually means that I get the bandwidth to myself on the internet, but who knows? Who knows what's going to happen that way? I was speaking with Mahesh the other day, not long ago, and I was explaining to him some of the cool projects I'm doing as I teach at McGill University. I'm an adjunct professor of software engineering. I teach a course I've developed called Software Validation, which is basically about testing as part of software engineering. It's a mandatory course. My students have to take it. They have to pass it. If they don't pass the course, they don't get their degree. So my students, for 3 months in their life, call me sir. And that's true, they do. But describing the work of the course, I was explaining to Mahesh with a matter of fact attitude that, well, we do a project which starts off the first third of the semester is about exploratory testing. and it's all test automation. And I was describing what we were doing, and Mahesh said, wow, that's something that's sort of inconsistent with his experience. And he had a lot of exploratory testing experience and knowledge, but for him, it's always been sort of a person who's sort of controlling an application or a system. And he never sort of thought of it from the point of view of automation and programming and things that are exploratory in nature, but require a lot of tools and technologies to get done. So I offered to share my experiences in what I call exploratory test automation. So I want to share some experiences in that with you. The format here gives us only about 45 minutes to chat, and of course Q&A for another maybe 15. This is a short amount of time for a subject that I might spend 3 weeks talking about. And I'm the type of guy who can spend 3 weeks talking about this, so I don't want to dive too deep. What I want to do is share with you guys some insights, some ideas, some examples, and I want to make available to everybody in the community, everybody who's watching or engaged in this, electronic copies of the examples and case studies that I'm talking about. And I also want to begin with the end in mind here a little bit and share with you that if you ever have concerns or questions about the stuff that we're talking about today, please do not hesitate to contact me. And I've asked Mahesh and the testing tribe to share my contact information and coordinates and make it accessible and available to you. I want to make this stuff real, if you will. Make it real. And it is experience-based. I'm not going to share with you a whole bunch of theory here. I want to share with you a bunch of reality. So let's start. I have to start with mythology. I love to start with myths. And it's incredible. I had 150 students this term, 150 students. And I gave them this project, and I was very clear. I taught very clearly what the deliverables were, what I was expecting them to do. And we did a lot of examples and exercises, and I showed them tons of case studies. And I would say about 10% of them started working on the project. And it's very good that we provide feedback as the project goes on, right? We don't wait till the end to give feedback. We give feedback every single week as they do the work. But we saw incredibly weird things being done and delivered. And like we had asked for this and they did that. And I trace it down to vendor claims. They had actually looked at tools that were available in the market related to the technology of the project, which at the time was microservice architecture with REST API. That's what we were testing. And it was a very beautiful little project. But they basically went out there, found some vendors who had tools that helped to test in this technology. And the testers had all sorts of claims about what the technology is and what the not just technology, but methodology was and terminology. And they were basically saying, this is how exploratory testing works. This is how automation works. And the tools were doing things that were automatically generating stuff. And it was all, for me, a myth. It's not true. That's a vendor claim. And it's a vendor vocabulary. And it's a vocabulary designed to tell non-technical people about benefits that have no bearing on the actual testing work. So I was very concerned about that. So I want to share with you the first thing is the 4 big myths about automation and exploratory testing. So the first myth is that all exploratory testing is manual. This is propagated in books, including one of the most important books on software testing available right now by Lisa Crispin and Janet Gregory on agile testing, which is I'm not saying it's a bad book. I'm not challenging the book. I just want to say that if you read it and you start looking at the model they're presenting, it certainly looks like they're using the term exploratory testing synonymously with manual testing. So that's a big book that a lot of people read that gives this sort of myth, which is not. And I'm not trying to diss the book. The book is fascinating and really useful. Vendor claims, so vendors all over the place, including stuff I just checked yesterday. It's very clear that they're biased, saying exploratory testing is manual testing. Whoa, what's going on here? And then there's actually published articles and conference talks that talk about that. So this is a big myth, that all exploratory testing is manual testing. Second myth, all automated testing is regression testing. And you start looking at how people structure test automation, and they're always setting it up and organizing it so that they can have repeatable tests that are going to be used for helping people find regression bugs when things change. And it's to the point of absurdity when you start looking at how much automation is structured that way, how many people have courses, books, technologies, tools, models that help you make nice, clean, repeatable automation scripts that have benefits and repeatability and all these characteristics. And I like to say, well, yeah, that's something that automation can help you with a lot, but just because it's useful for unit testing with JUnit and stuff like that, just because it's useful for acceptance testing or story testing with Cucumber and Gherkin and stuff like that, and just because people like to do end-to-end integration testing with it, that's just an application of automated testing. That's not all automated testing. In fact, that's very limiting. For me, that's sort of part of your software engineering process that is perhaps in some cases necessary, but is far from sufficient. And it limits you if that's what you think all automation is. And I've seen companies, monster companies, that have thousands of testers that impose this model on people and actually create rules about automation has to be this, has to be that, has to be the other thing. And they're actually limiting people from using it in other places. Third myth, all exploratory testing is ad hoc. Again, as recent as yesterday, I saw documented papers by people who are very respected in the field suggesting that exploratory testing is ad hoc testing. And I can give you I'll share files in the Dropbox with you guys. I'll put some examples of these papers there. But it's interesting. There's this notion that exploratory testing is synonymous with ad hoc testing. Now, it's true that some exploratory testing is arbitrary, random, and untraceable or not easily traceable. But that's not the case for all exploratory testing. In fact, if it was the case for all exploratory testing, I don't think that exploratory testing would have the value that it does right now. It would just be another name for what I like to term the term playing with the system. Now, we need to do some ad hoc exploration, but not all exploration is ad hoc. Not in any way, shape, or form. Next one is mythology of all automated testing is premeditated. Now, this would imply that you do automation deliberately to get a benefit, and the benefit is some sort of return on investment. Okay, maybe that's what some people do. I've structured courses and projects around these ideas sometimes if customers really, really want that. But it's not really something that is always true. You don't always need a framework. You don't always need to follow patterns. You don't always need to do things in a certain way. There are no best practices in my view. There's a lot of practices, but in context, different business, different technology, different organization, different culture, and the culture could be societal or team-oriented. All of these factors influence dramatically where and how automation fits in. And I like to suggest that automation is more like a blade on my Swiss Army knife of testing skills. And I want to pull up that blade when it makes sense, when I need it, and as I need it, not just because it's part of some existing framework. And this, of course, leads people, if you start looking at this, they lead people down a path which I call the path of zombies, the path of people who are template zombies that are looking at a pattern and looking at the structure and saying, all tests must be A, all tests must be B, all tests must be C. And then you sort of say, wait a sec, is this mechanizing testing? Where's the creativity? Where's the thinking? Where's the cognition? And it's really risky. So I think I look at automation as a tool set, and I bring that tool set to bear when I need to as I'm working on a project. Those are, I think, the big myths. And I'm not trying to categorize all the myths. I'm trying to say these are the ones that I get hit with a lot and recently. So, my reality, and I'm not prescriptive. I don't want to tell you how you should do things, but I want to share with you how I like to do things and how many of my customers and students have done this. And I can validate this against some very important software companies and projects going on right now in the world. First one, exploratory testing is cognitive. I do not use the distinction between manual and automated. That's absurd in my opinion. What I like to think of as exploratory testing is by nature a thinking activity. It is thinking, and the purpose of it is to learn things that are important to our stakeholders, important to our team. We're trying to learn. Our goal is to learn. And that's what exploratory testing is all about. It is a thinking process. So it is nothing about whether you hit the keyboard or you write code or you use a third-party tool or you just watch things from a distance. It's nothing like that. What it is it's learning. It's a cognitive process. Second thing, some regression testing is automated. That's my reality. Not all regression testing can or should be automated, by the way, and in my view. And regression testing is a great opportunity to use automation, especially in continuous integration. And I've been using automation and continuous integration since the late 1970s. Don't think this was invented yesterday by a bunch of DevOps people. Continuous integration goes back to, in my knowledge and experience, the work done by AT&T Bell Labs in developing the Unix projects starting in the late 1960s, early 1970s, with people like Dennis Ritchie and the Unix team at AT&T working on it. And that's where I learned about continuous integration. And that's what we did in projects that I developed as early as 1979 to 1982. And those projects had build servers, make files, and test automation scripts, and everything was focused on automating the regression. So we did that as part of continuous integration. So yes, some regression testing is automated and it fits nicely into continuous integration, but that's only part of the project. Exploratory testing for me is about deliberate learning. I'm not just learning randomly. I'm just learning for the sake of learning, although sometimes I maybe do when I'm teaching. What I'm trying to do here is I'm trying to emphasize that we have goals. I like to call those goals, using terminology first published by James Bach and his brother John in the late 1990s. I use charters. A charter for me is a mission statement. It's a goal for exploration. It's a statement of what I want to learn. So I always have some sort of learning goal when I'm doing exploratory testing, and therefore it's deliberate learning. I want to purposefully learn about a specific thing, and what that thing is very project dependent. But I've put so much thought into this that I actually wrote a book called Charting the Course, Coming Up with Great Test Ideas Just in Time, which talks a lot about identifying useful, meaningful goals for exploration. And I'll put a copy of that in the files I share. The last reality I want to share is that I come up with a lot of my best test automation on the fly. I don't spend months and months designing frameworks and developing methodologies. I look at it as literally like tool sets. And while I'm testing, I will construct or build bits of automation that are helpful to me. Maybe I'll write little batch files. I'll show you examples that are one line long, trivial batch files. I'm a huge fan of this notion of just enough automation that's valuable to me to help my learning objective. They don't have to be run thousands of times. They don't have to be regression tests. They don't have to be perfect. They don't have to be maintainable. They have to be valuable. So just enough that's good enough, that's on purpose, and does not need to work or last forever. So all this criticism of writing automation that has to last forever, that has to be maintainable, that, if you change the GUI, you have to rewrite all your automation. Baloney. I want to use automation to help me get my job done. Here, I wrote a little script. Here's what it is. And if I have to revisit that objective again in the future, maybe once in a while, I'll reuse that script, but I'm going to take that as an input to the new learning objective, rather than saying my project is not to maintain the automation script. My project is to learn. The automation is a tool to learning. So that's my reality, or at least some parts of my reality related to automated exploratory testing. Now, I should define things. So it's interesting. As a teacher, I end up sort of forcing myself to define things. So let's take a look here. My working definition of exploratory testing that I've been using forever and for always, including before I worked with the workshop on teaching software testing and workshop on test automation in the early 2000s with Kem Kainer, James Bach, and all these people to try to define the practice. I always thought exploratory testing was concurrent design and execution of tests while I'm learning. So that, to me, is my sort of always in my head. It's tattooed to my brain. That's what exploratory testing is. I'm designing and executing tests while I'm learning on the fly to some sort of goal. Now, Dr. Kainer, who took a lot of effort to try to formalize parts of exploratory testing as part of his great body of work, and I just love his work, and I had a chance to work personally with him for many years. Exploratory testing is a style of testing emphasizing personal freedom and responsibility of the individual tester to continually optimize the value for work by treating test-related learning, design, execution, and interpretation of results as mutually supporting activities that run in parallel throughout the project. Dr. Kainer's, this is from his blog on the craft and community of software testing, also been published in different articles and different forms, and is often quoted. He's saying what I'm saying: concurrent design and execution of tests while you're learning, and basically it's up to the tester as they're testing. It's not prescribed. We don't tell you technically how to do the job. We're telling you, hey, here's the challenge, here's the goal, you have skills, apply your skills to solving the problem. To do the work, you need the skills. Okay. So what do I call test automation? Well, I could go to Wikipedia and look at the 1,000 some odd words they use to describe it. But the gist of it for me is very simple. It's, I want to use tools. I want to use tools to support my testing effort. And I want to use the type of tool I call programmable tools. We are testing computers. To control computers, we program. I want to use computers to test software on computers, or to test hardware on computers, or to test people on computers. I want to use programmable tools to support my testing efforts. That's what test automation is. It is not in any way, shape, or form a return on investment argument of replacing manual testers with machines and tools. That's not what I view automated testing as. I just say it's using programmable tools to support testing efforts, part of which could be your traditional regression testing models. But for me, it's much broader than that. I want to master the use of some of these tools so that when I go to a new project, I will use these tools. And the tools for me are maybe a little bit more broad than some people would think. I'll be very specific about what I use the tools for. This is what I call what automation helps me to do. So just be clear here. I'm trying to just give you some background before I dive into my little case studies. So first one, I use programmable tools to help my observation. I love to look at this with a scientific approach and saying, if I'm trying to learn something, I want to basically be able to observe things. Tools help me observe things better. They give me more acuity. Did the screen change? The tool will help me better than I can do it by just my eyes. Did something happen that takes a few milliseconds? I can't measure that myself. I need a tool to help me do that. So acuity. I want to be able to, have a sharpness and keenness. I want to be able to see things which are in, there, little glitches, little things. I want to be able to get nice acuity. Then fidelity. I want to be able to have accuracy, exactness. I think tools help me do that. I can sort of repeat something or create something deliberately and exactly with a tool. It's very hard without a tool to do that, but with a tool I can do that. So this is basically fidelity. And volume. I want to consider quantity. I want to say, hey, I'm doing some work here and I'm testing a transactional system, and I did this actually many, many times in my careers, but I've got experiences doing this. And I suddenly realized, wow, there's like 10 variables and each one has many options. There's billions of possibilities. And I want to find a subset of them. And sometimes I just need to sort of say, let's write a little script so that I can do 10,000 operations with random values to check it out and write a little code to check if that's correct. And I'll use this because I want to try 10,000 things, not 6 things. I don't want to limit it. I want to basically give myself lots and lots of opportunity to try lots and lots of things. So this is volume. And I like to do this for certain testing things which require that sort of opportunity, that sort of testing thinking. Let's try lots of variety on lots of things and see how the system behaves. So the automation helps me do that. So broadly, this is observation. I want to also observe things like, hey, I have 10 trillion pieces of data. Let's use some automation to help us turn that into meaningful stuff. So this is like statistical analysis and aggregation of data and studying patterns of data. Control, second thing. Automation helps me control applications. Now, this is the traditional one, right? Simulating input. Okay, yes, I do use libraries to help me simulate input, especially today, stuff like Selenium WebDriver or Water, the tools, the libraries under Ruby, or any library I can get my hands on that basically simulates feeding keystrokes to an application. So this is simulating input, but also I can simulate input at the message level. I can simulate input at the API level. I can program through the any exposed application interface, which is more and more common today for microservice architecture. And I can also control applications by manipulating data external to the application. So this is control. Observe, control, observe, control. You control, you observe. If you can do control and observe, you can basically do a lot of great learning, and that gives me a lot of great testing. So these are the two primary things I use automation for. So I didn't say framework, right? I didn't say regression. I say I want to see better and I want to manipulate better. I also love to do this, and I've been asked to don't forget to talk about this. I use automation to help me design tests, tools that are programmable that help me design tests, to help me identify variables. And today, there's all sorts of tools to help me identify variables. This is not saying that all the variables the tool helps me find are the ones I care about, but it gives me at least some interesting technical information about variables. I can do combinatorics like pairwise test analysis with tools. I can do path analysis if I can visualize a system under test somehow with a directed graph model. I can do path analysis on it, and this is automated things, fantastic tools that I use to support this. Some of the best testing I do is with path analysis, and all sorts of permutations and combinations, which are getting better and better and better, and awesome libraries, especially in Python today. So that's designing tests. So observe. Automation helps me observe, helps me control, helps me design tests. It also helps me assess correctness. This is the test oracle problem. It helps me implement heuristic models, which is really cool. I can look for things that are sort of indicators of potential problems and then sort of feed them to human beings to say, hey, is this a real problem? I can try to identify interesting situations that might require, like I'll use the tool to say, hey, this is interesting, but I'm not going to say it's right or wrong or good or bad. I'm saying it's interesting. Let's look and dive into it more. Or I could do, and I have done, side-by-side comparators. I love this, especially for migration projects or something that where you're adding a new feature. You want to say, did the old version work with the new version? You can get side-by-side comparators and write tools that do that. And it's very graceful to do this. And it doesn't have to be super-duper general purpose. It can be very specific to one charter of exploratory testing. So it's simple side-by-side stuff. I use tools, automation tools, to help me with dynamic analysis. While I'm doing this presentation right now, I have a dynamic analyzer telling me about the network bandwidth and the CPU use and the memory use of my systems. All of these tools are running while I'm testing to tell me about how my system interacts with the software, looking at attributes and doing this dynamically. And I can do this programmatically. And I do often, and I would say almost always, I do dynamic analysis. I can also do static analysis, and I can write my own scripts or use tools that help me do this to identify all sorts of risks. So you can imagine I am using automation to help me identify risks, to study behaviors, to assess correctness, to design tests, to control and observe the application. Blades of a Swiss Army knife. Automation helps me do probes. Probes, little programs that run in the background while I'm testing. They're probes. And I basically want to trigger an event. It's going to run and wait for something to happen. It says, hey, Rob, someone logged in. Hey, Rob, the data changed. Hey, Rob, you're running out of memory. Hey, Rob, your CPU is saturated. Hey, Rob, there's more users than you can handle. These are just probes that you run in the background, and they basically can give you messages so they can trap events. We can also do data integrity checks, especially if you're worried about does your application accidentally screw up a database. So many people focus on testing functionality that they forget to take a look and see, are we screwing something else up? Are we breaking something else? I can use automated probes, little ones, 15 lines of code to help to check data integrity. And one easy way to do this is something called field checksumming, where you basically just write a script to go through the fields of a database and you sort of add up all the values and you see if that sum matches the previous sum of the last time you added up the values. And if they're different, something's changed. You don't have to do a comparison of every field against every other field and do all this huge analysis. Just do a checksum. It's trivial, and it tells you when there's a problem. It doesn't tell you necessarily what the problem is, but it tells you when there's a problem so that, again, you can feed that to a human being or another tool to say, hey, what record got corrupted that wasn't supposed to be corrupted? So these are probes running in the background, probes like in Star Wars, or probes trying to find out what's going on. And the last in my list, although this is not a complete list, this is just stuff like I did recently. Non-functional testing. Did some beautiful non-functional testing recently. Tools, automation tools, programmable automation tools help me. And with stuff that's maybe not obvious to you, but usability testing, especially eye tracking technologies, performance testing, time-oriented performance testing, load testing. How does the system react with a lot of traffic and data? Stress testing. How does it behave in harshly constrained environments? All of these types of testing, I use all sorts of programmable tools to help me do. So automation helps me do a lot of stuff. It's not just one thing. It's not just running JUnit scripts. It's not just running Cucumber transactions. For me, automation helps me do a lot of things. It helps me learn a lot of things. I do have some comments about tools that I favor, although I am not a bigot towards any one tool, and I'm usually lean towards open source tools, but I create my own all the time too, because I'm an old Unix programmer. So I start with the, if you will, scripting languages. I urge everybody in the software testing world to forget about this designation saying, are you a technical tester or a non-technical tester? Are you a manual tester or an automated tester? That's nice designations. I'm sure some companies benefit from it. I'm sure some testers benefit from it. But what I urge you to do is to learn a little bit about scripting. Learn a little bit about scripting. Perhaps the best reference book on the subject that's been written that I know of to date is by Brian Merrick, and it's basically called Everyday Scripting with Ruby. I know it's a Ruby book, but it tells you about scripting, and it's designed for non-programmers without degrees in computer science. I urge you, learn some scripting. So I started in the old days. I learned shell scripting. Shell, C shell, corn shell, bash, all these shell scripting languages. That's my starting point. I learned shell scripting, and I didn't have to be a guru at it, but I knew I had to learn some of the basic concepts of shell scripting to get things done. Then I learned stream editing, sed, lex, yak. Those are all Unix scripting tools. And as I got better and better, I learned more complex ones. There was one called awk that was a fantastically powerful one, but unfortunately cryptic, so no one could understand my code. I then moved the book name, Brian Merrick's book, Everyday Scripting with Ruby. And I will include, the bibliographical reference in my files that I share. Everyday Scripting with Ruby. In my opinion, for me, most influential book on scripting for testers, especially non-programmers. Awk was beautiful, powerful, useful, but no one could read my scripts, so I learned Perl. Perl was wonderful. I could start doing really cool stuff. But Perl, again, was a bit cryptic. So Unix stuff is almost always cryptic. Then I learned Ruby, bang! Got out of the world of cryptic, got into clean-looking scripts. The reference by Brian Merrick, fantastic stuff. Ruby was, for me, great. However, today, if you're going to learn a new one, probably the best one to learn is Python. Python is awesome. I'm not saying it's better or worse than Ruby. It's just awesome. And it's awesome because it's got a great community of support. It's syntactically friendly, and you can really do great scripts with Python. I've got lots of examples of Python scripts I'm happy to share just to do combinatorics. It's wonderful. And then, of course, there's old school stuff, Visual Basic, which is a beautiful story by itself. Visual Basic started its life as a testing tool at Microsoft, and it was so powerful a testing tool that they turned it into a programming language. But VB is something that, again, it's a scripting language. I frankly was very good at it in its day, and I do a lot of test scripts with that in the right context, on the right platform, still today. And recently, for working with microservice architecture, the history of VB is an interesting thing. That's a whole talk by itself. Curl! Love Curl! Curl is so trivial, so simple, so beautiful. If you want to muck with REST APIs, you can go and buy a tool or use a tool like Postman, all these tools. They're great, nothing wrong with them. But Curl, it gets you down. It gets your fingers dirty. You get to control the HTTP level, and it's easy to use and very powerful. It's so super duper. It's wonderful tool. I love Curl. And I mean, just awesome the fact that it works exactly syntactically similar on Macs, on PCs, all over the place. And so Curl is sort of, for me, so trivial and so beautiful and so simple. And in fact, Curl works also, it's a command line tool, but it also, scripting tool, it's also something that has libraries that you can use with almost any imaginable scripting language or programming language. So you can get Curl in Java, Curl in Visual Basic, or Curl in Python, all of these things. And I've even found some resources that help me to say, hey, if I got a Perl script working in Ruby, what would it look like in Python? And this has been very helpful for me for syntactical stuff. So sometimes I'm very lousy at remembering syntax, right? So anyway, those are just some of the scripting languages. I find the skill that I want to encourage you to learn is how to not get too attached to a scripting language and to learn new ones. Like, so many people are putting their resume together saying, I know this tool, I know that tool, yay! Well, I want you to show me not that you know a specific tool, but that you can learn new tools as they come, because every year there's new ones, and every couple of years you really have a big shift in the market. And this has been going on for me since I started. I mean, I wrote my first code as a kid when I was 12 years old, 1972. And we had some weird scripting there to manage punched tape. And nowadays, scripting in Python is sort of all the rave. It's beautiful, but there's more scripting languages. There's domain-specific ones. Learn how to learn scripting languages, and don't get buried in the syntax. Learning scripting is not learning the syntax of a language. Learning scripting is learning the sort of logic of the language. So this is, anyhow, scripting. Tools I favor. Let's get case studies while we have left here. First case study. This was a crazy example. It was really interesting. I was working at a company called My Virtual Model, doing the back-end software for landsend.com. It was hilarious. I would go to testing conferences, and when I went to a conference, people would talk about performance testing and always use the example of landsend.com. Well, you're looking at him. I set up the software engineering infrastructure for the back end of landsend.com. That was me. It was phenomenal. It was fantastic. And it was called My Virtual Model, the project. And basically, during it, I set up teams, I set up processes, I did all sorts of cool things. I had in my back pocket a lot of scripting, a lot of test automation stuff, and I ran into a problem where I had to, at one point in time, I had to figure out whether Land's End was selecting the right clothes given a model of a person. Now, a person was described with 192 parameters. That's describing you. A physical model of you so that you can buy clothes. And Lands' End was a very ethical company. And if you got the wrong clothes, what they would do is they would give you your full money back, plus a refund, plus a credit, plus they would pay the shipping and give you the right stuff. So it was very important for their tool to find the right size. But to test this, I realized it wasn't just an algorithmic thing. We actually needed to talk to domain experts about size. And it's like size depended on something called the type of person, which wasn't really quantified. It was a subjective assessment of the fashion designer. And it was really cool to work with these domain experts. But how do I do something like this? How do I test sizing every single product Lands' End tests with domain experts, which don't know anything about technology, but really know fashion? So the first thing I did was I built a little baby keyword-driven framework. So just to talk about keyword-driven frameworks, let me go to my keyword-driven example here. Again, these files are going to be in the Dropbox I share. So there's the keyword automation, looks like this. So what we do is we have a script that we write that takes data from a data source, interprets it, controls the system under test, and logs the result. So this script for me would read a data source. The data source basically was just a whole bunch of records, one line for each test that would run, and it would have 192 columns for all the parameters. And then the script would basically control the system under test using, and this was basically manipulating a front end with a scripting library, and then logging the results. Now, I didn't assess correctness. I logged the results. But what I would do here during this, basically, the data source would basically be parsed one record at a time, and then I would control the system, interpreting the parsing, and basically log the results. And I call this, so there's data-driven style where it's the same transaction every time, or keyword-driven style where it's different transactions every time. Now, this approach, if you look at the picture here, right, is pretty generic, and I do have examples that I build from, so I don't start from scratch every single time. But this, I don't care what the programming language is. I've done this in Perl, VBA, Ruby. I haven't done it in Python yet, but I mean, it's very easy to set up a simple data-driven framework. You shouldn't try to generalize it. You should build your first example and then learn how to do it, and then the structure will follow you forever and for always. So that's what I did for the case of my virtual model. And I include also the source code of an example one I've got here, just to pull it out for you. This is a Ruby example of a keyword-driven framework using, this is a Windows application. And what you're doing in the end of it is you basically, what ends up happening is you get to an inner loop in this. So you parse one record at a time, and then depending on what the keyword is, you basically call some sort of testing logic. So all you do, this is the whole thing. This little case statement here in the middle, that's the logic of the testing here for the simulating. This is control. So basically, it's just a simple construct called a case statement, not complicated to do at all. I'll include source code of an example or two of these in my Dropbox files. But what I did then was I basically randomized these inputs, made about 10,000 samples, and I reviewed the examples with a domain expert, which only took a few seconds per sample unless there was an anomaly. I logged in a database what the results from the domain expert is, and then basically I set up a program, a little script, that would basically check, okay, what is the result the software gives me? What is the logged expected result from the domain expert? And if it was different, then, okay, flag that, and we better talk to domain experts again. And there was all sorts of weird cases like that were really super duper. So that was huge. And we were able to basically challenge this project, take this problem, and we didn't make scripts that had to be robust and run forever, because every single day on this project, the user interface and program was changing dramatically all the time. So we basically just sort of ignored that and just did useful stuff to help us learn on our objective. Second thing, exploring REST API. Big project I did this year. I had over 150 students working on this. Exploratory testing of REST API. The cool thing here is that we had a charter, This is a charter. This is the exact charter we used. I will include this in the Dropbox. So identify capabilities and areas of potential instability of the REST API. This is To-Do List Manager, a beautiful example put together by Alan Richardson. Identify documented and undocumented REST API tool list manager capabilities. Not everything is documented. You can't find everything from tools like Postman. You have to do other stuff. For each capability identified, so when we identify a capability, what we want to do is create an example script or a small program to demonstrate the capability. So when we're doing reconnaissance charter, this is reconnaissance testing, we're basically trying to learn about the system, and we're going to document our learning by making little scripts that do things one function at a time. Our script, the job is not here to try to break the thing we're testing. It's trying to learn. Hey, here's an example of how to do this. Here's an example of how to do this. And if you identify 50 capabilities, you have 50 examples. And it's really neat because those examples are going to become building blocks for future stuff that you're going to do. You're going to build little libraries. So each capability identified, try it. We exercise it with typical data. So you have to know what the intended use of the application is. So this was the charter that we used. And as people did the exploratory testing, they built scripts. So if I can share with you an example of, so this is just an example, a little teeny weeny example, one line curl script that basically is basically trying to look at the list of projects or something like that. So what we have here is we have a curl statement with some parameters to describe the credentials, describe the type of content, and this tool could this REST API worked with XML or JSON, and then we had in a file we had the XML parameters needed in a separate file. So we basically figured out how to do this. We captured this. We made sure this did what it was supposed to do. It was an example. It wasn't trying to beat it up. Another example here. Another example there. This is one doing a delete operation. So all of this stuff, very clean, very simple. We built Ruby scripts. The Ruby scripts, short little scripts that basically did things like this. This is one is trying to delete things, and there's an object called a context. We want to delete a context by name, so we basically wrote the script. The script is I don't know how many lines. The whole script is 75 lines, including space and comments, and it's just a couple of simple loops. And in the middle of it, what we're doing is we're actually going to be calling those batch files. You see here? This is calling the batch file I created. So it's just using what Ruby has as a system directive to call a batch file. And it's wonderful because you call one script from another script, and as you build these little atomic things, you can construct them. So I'm building libraries on the fly as I go. So that's, and again, I'll throw that in the Dropbox files. You'll see some examples of that. But we did a lot of these, and it was beautiful because from those libraries, we learned about things, we found bugs, we did deeper exploration, we identified new charters, new opportunities to test. Third one of my most fun recent examples, company called, sorry if I'm taking a little longer, I just want to share this one. Seva Search is a tool that's similar to Google that tries to raise money to help people who are starving around the world. They want to end world hunger. And so they created a tool, and they claim that it's comparable with Google. They've asked people in the testing community to help them on a volunteer basis. I jumped in. I worked with some of my McGill students, and we basically said, okay, let's check that. Let's challenge the claim that Seva Search is similar to Google. How do you test that? How do you test that? Well, basically, we had to learn how to test that. And that's testing, learning. So it was awesome. So we made 3 charters. The beginning was, okay, let's learn how to create a script to identify N non-ad based URLs from a Google search. So you do a Google search for a term, you ask for N results, whatever N is, a number, and then you strip out the ads and just look at the N search results. So that's the first charter. Can we do that? And we made a script that could do that. Then the second one, and this was, of course, some of that was published, some of it was not published. We learned how to do that by experimentation. Then we basically created a script, the second charter, learned how to create a script to identify the same thing, but from Seva Search. Seva Search looks like Google, but the API is different, and it's not as well documented. So we had to study, explore, and learn. And then the third charter was to create the script that compares the results of Charter 1 and Charter 2, looking at the similarities and the differences. So this gave us fascinating insights. And by the way, they're different. They're not the same. They're not comparable. So Search is going to find different things than Google for the same search string. So we learned that. Now, just to show you the test harness here, if I've got it up and running, I don't have it up and running. So I don't have that one available. Let's see here. No, that one is not available. I will have to share that one with you guys I'll share that one. I don't have it on my screen here. Sorry about that. I will share that one in the Dropbox files, but it's basically graceful. The inner loop one is about 10 lines of Python. Beautiful, beautiful, beautiful script. And the last example was a medical software system where basically we set up scripts that took log files to replay transactions. So using the HL7 protocol, if you're interested in that, that's a Perl script that I'll throw it in also in the Dropbox files. So just to share some examples, I'm basically using automation to help me learn, and I'm not trying to create automated regression tests. I could create automated regression tests and use exploratory testing to help me design them, but that's not my limitation on what I'm doing here. So that's the end of what I wanted to share. Sorry it took a little longer than I expected, but I wanted to leave some time for questions and pass it maybe back to the facilitator to help with questions. Hello.
Hi, Rob.
Hi, sorry about the timing there.
No problem. We were loving it, and this was just amazing. A quick guideline to the audience: use the questions tab you must be seeing at the right panel for all your questions which you may want to ask to Rob.
Is there a tab I should be on for the questions?
You should be seeing it just below the chat.
Just below the chat. Let's see.
Right.
Let's see. I see the chat. Oh, yeah. Got it. Questions. No questions yet.
Let me check if
do we have an audience? Is there anybody watching us?
Yeah.
Just to reiterate, so I will share those examples that I talked about, so you can let it soak in.
Let me check if we have any question on Facebook and YouTube. Meanwhile, we have a message from Pradeep for you. So Pradeep says, "Hey Grandpa, I love you, and you are awesome in the field of testing."
Grandpa, yes, that's Pradeep's nickname for me. Thank you very much. I love that. By the way, you can call me Grandpa too. Somehow it's cultural. If the question I see here is, if you had to list out the top 5 parameters to learn about across programming languages, what would they be? Parameters to learn about programming languages, what would they be? I guess I've never looked at it from a point of view of what are the aspects of a language to learn. Certainly, I want to learn how to manipulate and represent variables. I want to learn what is particular nuance of that language. Is there sort of like a model I have to understand to benefit from the language? So I want to learn how things are represented. I want to learn if there's a model associated with that language. I want to learn how peers have used that language to solve similar problems. I'm not doing that to find patterns necessarily, but I want to have a community to talk to learn about that. I also always start with hello world. So I want to learn how to create a simple hello world application with the language. So that's something. And there's, of course, how that language can interface with other objects is something I'm really concerned about. So I'm not too worried about the language in and of itself. I'm worried about, can I, for example, call a Ruby script from a Java program? Can I call a curl script from a Ruby program? Can I call a Ruby program from a Python program? How do you do that sort of thing? And I don't want to get too technical on it, but I really, really believe that I don't want to bind myself to one technology. I don't want to say, hey, I'm moving to this scripting language, so I have to throw out all my knowledge of other scripts. No, different strokes for different folks. Different problems are solved differently. Okay, so next question. Do we just do these linearly, or do you want to pick your favorite ones?
No, you can go in any sequence, Rob.
Okay, well, it's just that I can only read one at a time. So did you ever exploit existing regression test automation in your testing? Yes, but not the way you think. What I do is, if I'm a manager on a project and I can influence change, or if I'm an architect on a project and I can influence change, I really, really, really ask people to build things at a library basis. And I try to create a library of what I call orthogonal, little baby independent functions. And that library I then can use for creating, for example, step definitions in Cucumber. I can use that library to create JUnit controls. I can use that library for any test. And what I want to do is know that basic library. And the library does little atomic orthogonal things. There's nothing complete about it, but it does something useful. And so I could string together these library functions. And yes, if I'm building if I'm architecting a regression suite, I always try to make reusable libraries as part of my job there. And that helps reduce the maintainability of regression. And it also gives me fantastic tools for exploration. And I love everybody in the testing team to know how to use the fundamental parts of that library. Okay. Let's see. I'm losing the questions here. So what is the easiest way to automate exploratory testing? Easiest way, I think, basically learn a scripting language that people on your team know. So learn a scripting language, and then think of the things that I'm looking at. When I said what automation helps, when I talked about the things I like to do, pick one. Start with observe and control. So if you want to start, I think that's the easiest way to start. Observe and control using a scripting language that other people on your team is familiar with, so they can offer you a little bit of coaching and guidance. And once you've mastered observe and control, then you can dive into assessing correctness, designing tests, and other things. So that's the easiest way to automate. Let's see.
I'm moving the ones you have already answered, so that you can just find it easy.
So, okay, because every time someone types something, it scrolls and I lose my point. I'm convinced, trying to figure out how to present this approach on the powers that be at work by getting buy-in. Okay, well, I think that this is a big problem in some organizations that have what I call inertia. And if they have a model that they impose on people, the lone tester to change that is very tricky. I wouldn't go on a hunger strike or anything like that. What I would do is I would demonstrate value. So I would wait for an opportunity to do some exploratory testing and do it without asking for permission. Just do it, and then demonstrate the incredible value of what you've done. And that will start building momentum. And especially if you could find technical champions. Your business stakeholders are not technical champions. They have business goals and they have methodologies that they believe in. You don't have to change them. Their goals are not wrong. They just have a bias that is to one solution space. Say, hey, the world's changing. We've got to look at exploratory testing maybe differently, and automation maybe differently. But do examples, demonstrate the value, and that will build momentum. A lot of context factors. It's hard. You got to build your creds. It's very tricky. To build credibility with this, you have to really demonstrate it. So look for opportunities. How do you think machine learning will have impact used for exploratory testing? I think machine learning is a great application area. and it is really freaking cool. I want you to not just talk about machine learning. I want you to learn about the methodology behind it, learn about the theory behind it, learn Bayes theorems, learn the basic ideas, and those things are helpful because in testing, when we're talking about massive big data with gazillions of terabytes, we need to infer things from it. Machine learning technologies is great at that inference. So please, please, please learn about the basics behind it. Don't worry about the abstract application layer. Worry about what is going on, the fundamental theory behind that. And again, I say Bayes theory. I am not an expert in it. I am loving learning about it, but I go down to the roots of it. I don't want to get caught in the application space. If then you'll look at the vendors, tool vendors are starting to say, hey, we have machine learning, blah, blah, blah. And you look at it and say, well, what is it doing? What is it learning? Is that really what I want? We're not there. We don't really have self-driving cars yet, and that technology doesn't replace the cognition of a tester. So the machine learning is going to be a very helpful blade on our Swiss Army knife. Learn as much as you can, but learn the theory behind it, the basic underlying math behind it, and then you'll be able to apply it on new projects. At what time should exploratory testing be involved in Agile method? In Agile methods, assuming you're using something like Scrum, I like to suggest that exploratory testing is very, very handy and should be identified at the beginning, my experience, in the planning meeting. When you're breaking down for any one story that you're implementing, identify testing objectives using different methods, different types of testing objectives, capabilities, failure modes, usage scenarios, creative ideas, all sorts of them. And basically do that in the planning meeting to identify basically what are going to become your charters. But always start for each and every charter. Each and every story, when you start working on testing it, start with recon. Do reconnaissance exploratory testing when you start to try to identify risks that were not explicitly available by looking at the story, looking at the requirements, looking at the planning. There's stuff based on what I call reality. What's the real change to the code? What's the real environment the user's in? What's the real job the user's trying to do? And those three things will impact your exploration. You can do that when you do reconnaissance, when you start testing a story, when the developer is basically ready to hand it off to you. And you can do it before, because you can do exploratory testing paired with them in the IDE. I didn't talk about that today. That's semi-automated testing. We're using the IDE. That's my Agile experiences. I could talk about that for hours. Maybe we should do another webinar just on that one. At what time should exploratory testing be involved in Agile methods? So that's what similar thing. Should you leverage developers' language to help when facing new technologies? Yeah, well, you want to not leverage their language, but you want to basically make sure that you're not alone and you're not isolated. So I think you should use a technology that's familiar with the team when you're starting. Your job is not to teach them a new technology, but to basically communicate with them, and it really helps technical collaboration if you're using things that are similar to the technologies that the programmers are using on the team. That's just, for me, the collaboration technique. It's not necessarily the best solution for your testing. Eventually, once you know many, many scripting languages, you can choose the one that's appropriate for the problem at hand. But when you're learning, it's better to keep very close to the stuff that the developers are using, in my experience. What's the easiest way to automate exploratory testing? Hey, I don't know. That's good. What is the easiest way? You hit your head against the wall until you learn. You keep trying. You have to be able to fail safely, I guess, right? So don't try to use automation always. The goal is not to automate. The goal is to learn, and just figure out how to learn better, better acuity, better visibility, better visualization, better control. Don't have this notion that I have to automate all my testing. Saying, no, I want to learn better. I want to sort of use tools to help me learn, and start with real learning objectives that matter to you, and that's a great thing. In terms of training, there's great work that's been done by many people. I always like to point people to Alan Richardson's work on that, because he really, when he teaches stuff like how to do test automation with Selenium, he's showing you a lot of exploratory testing in there. It's how to use Selenium. It's how to do exploratory testing with Selenium. It's really like awesome stuff. So that's direction I'm pointing out anyhow. Your opinion on the testing versus checking debate. Yeah, okay. I don't find it a debate. I know very, very well Michael, and I know the Association for Resolved Testing, and I know the context-driven community, and I know a lot of why that is an interesting thing. It's a vocabulary that lets us distinguish between testing that involves repetition, and it's primarily confirmatory in nature, versus testing that involves cognition. So it's not, I don't consider it a debate. I think that your job when you're doing work is to learn. And sometimes what we want to learn is, is the behavior consistent to what it was before? And so you're going to do a heck of a lot of checking. And when you find something that doesn't check out, you got to do a lot of exploring. So it's not for me a debate. It's just that some of the activities you do, if you delineate them as checking, become mechanizable and definitely handy to do for regression purposes. I'm afraid that many developers get buried in this and sort of think, hey, the whole point of testing is to do this automated checking, and that's not true. That's just a small part of testing. But I don't really consider it a debate. I think that sometimes we have to learn. And we have to check, did things behave now the same as they did before? Does things conform to a requirement? That's checking type activities. And Michael's very wise to share that. And then the notion of testing as learning is true. But when I'm testing, checking is one of the ways I test. But it's not the only way I test. Most of my testing is broader than that. So I can probably talk for 45 minutes just about that one. Don't lose sleep about the debate. If the model helps you do your job better, create tools to help to do that. Use it to your advantage. If the model just confuses things for your stakeholders, step back and say, why should you worry about that distinction? I worry about the distinction because it helps me do my job better. It helps me learn better. But that debate that you read about, it's useful for some people. It may be useful for the community to discuss it, but use it wisely. Don't confuse your stakeholders. I see some hidden questions, so I guess those are done. Next one. From your presentation, could you say that automation and exploratory goes hand in hand when working with testing? Yeah, sure. I don't see anything else. I think that I learned to test that way. I've been doing automation as part of testing since the time I started. I never knew other ways to do it. So I'm always writing scripts, doing things with tools to help leverage me. With a lever, I can move the world. It is a lever. It is leverage. I want the tool to help leverage my cognition, help me do better work. So yes, hand in hand. I would say that, and you can quote me on that. Next one from, let's see. Okay. What do you think about the idea of heavy moving automation from UI to API testing? Well, sometimes I think it's important for me to test through a user interface. When I'm testing a user interface, I spent 10 and a half years in multilingual computing. I used to have to get systems running in 57 different languages on the same build. We tested the user interface. We tested the menus, dialogues, controls, methods, all of the user interface. When I'm testing the user interface to make sure the user interface is what the user needs, I basically test through the user interface. When I'm testing the business logic or the application logic behind it, I personally hate doing that through the user interface. I like going through an exposed API. I've been doing that since the dawn of time. And the structures of systems I did, the Quarto graphics package released June the 4th, 1982, was completely tested through an API. This was not invented by the microservice architecture people. So please, please, please distinguish it. Testing through an API is testing at a layer that is programmable and controllable, and testing the business logic of an application. It is not testing the GUI. Sometimes you can test the business logic through the GUI, but you don't always have to. I don't see this as being an issue. It's tool vendors like historically Mercury, HP, that have really aggressively promoted testing automated testing through the GUI. I think that if all that time was spent testing through an API, you would have had some tests relevant to the GUI tested through the GUI, of course. But testing the business logic, I've always found it cleaner, easier, and more manageable to test it through an exposed API. And just you have to do some integration testing to make sure that the GUI talks to the API right, but you don't have to test all of the different permutations and combinations of business logic through a GUI. You can test it through an API. So yeah, it's an issue for organizations that have a sunk cost in capture playback automation based on history, based on claims, based on investments. It's hard to get them to change. I wouldn't try to get them to change. What I would do is wait for a next big project and use different models. Big example, major insurance company in the States, that's exactly what they did. They had a huge investment in capture playback with HP Technologies for their beautiful, beautiful insurance applications. They had to have teams of people to maintain them. It was super expensive. On the next gen, they moved to testing almost everything through exposed APIs for regression purposes and still using capture playback automation for GUI sensitivity. All right. I don't know if I got distracted there. About heavy moving. How to perform exploratory testing when deployments happen. CI/CD, some insights, please. Well, this is what I call the move I make to don't stop testing on the live system. And basically, I would say that we should have a tool set that allows us to explore the live system. And basically, I move towards dynamic analysis tools to watch for things. The probes I talked about have background processes checking things, and those type of tools on live systems. I think after deployment is made, do that. I've got a case study, a beautiful case study on that. I will throw it in the Dropbox. The company's called Hairspray in the case study, but if you read it, it was at the time I did the case study, the world's biggest social networking company. And it shows how that was done. Again, it's basically tools running in the background on the live servers, and then human beings looking at the results of that and figuring out how to act on it on the live system. So that's some insights about exploration on CI/CD. Make lots and lots of tools that are probes, basically. Last question, I think, in the list here. Again, there's so many. Should we perform less UI automation in microservice architecture type of program? If yes, all right, let me just be clear here. When you're talking about user interface automation and you're talking about REST APIs, the user of a REST API is a programmer. So the way a programmer uses a REST API is by writing programs. So if you're testing a REST API, remember that the user of an API is a programmer. Distinguish that. Keep that in mind. Everything you know, all those good practices about testing the user interface apply to testing an API, because an API is the user interface for a programmer. So I think you should do both. And I think that a UI automation has its place if you're testing the UI, not if you're testing the business logic. Break the two down. Now, I agree, though, with making smoke tests through the UI. I love to do that, and I love to do some disposable automation in that area, but I don't believe that it's important to do all of your business logic testing or all of the data layer testing through the UI, but you do have to test the UI. And believe me, with platform compatibility risks, that is still an important thing. Don't throw out your UI automation tools just because I'm making a speech here about exploratory testing. It is an important thing, but break the problem down. Test the UI. Don't test all of the business logic through the UI. If I can make that distinction, that's my wisdom on that point. Is that the last one? I don't know. Smoke test is a term that's used in continuous integration world to basically try one or two transactions with normal data. So a smoke test is basically just to sort of say, does the application basically work? Is it worth doing more testing of? And I do that type of testing very often through user interface. So a smoke test is just a simple test to say, does the application basically have integrity? If the application has integrity, then it's worth investing more time to test. If it fails the smoke test, there's something wrong. It doesn't have integrity, so we maybe shouldn't invest more time on it. That's what I meant. Why is there a buzz about testing pyramids? How much is it useful? Wow. I don't want to get political here, but when Mike Cohen drew that picture, he was making a model to explain a concept. That's all. That picture is not tied. People think it's an agile pyramid. That's actually tied to a type of architecture that was popular in the 1990s, which is called a multi-tier architecture, which was popular probably still up to about 2010, 2015. Nowadays, people are using distributed service architectures more. When you're doing an architecture which is multi-tier, you have different tiers. The user interface is a tier. The business logic is a tier. All these things are tiers. And so drawing pyramids was sort of breaking down and saying, well, how much automation is used at different tiers? And sometimes people use that picture to make a point. I'm very cynical about it. I can show you projects where you could turn that pyramid upside down and it makes sense. When you turn it sideways, it makes sense. It's just a model. It's been used. It's not a buzz. Don't try to say, hey, on my project, I must conform to the model. The model has been useful for teaching concepts. Unfortunately, standardization bodies, such as, but not limited to the ISTQB, have sort of made that model into part of a syllabus, and people who write books use that model a lot. It's just a model to help teach concepts, not a truth, not a verity. However, ironically, if I look at real projects, I've got some example projects where we have, if you're looking at the pyramid, something like something in the order of 100,000 automated unit tests that are run on every build, about 1,000 to 2,000 automated integration tests for every build, and maybe a couple of dozen automated user interface tests for every build. So it does actually fit the pyramid model, but it's not, don't be prescriptive about that. That's, you might have for a microservice architecture a much higher amount in the middle. So it's not going to look like a pyramid. It'll look like a sort of a trapezoid where the middle is fat because the integration layer through the API is big and everything is tested through the API. Also, don't limit yourself. Use tools like JUnit to develop tests that are not just unit tests. So anyhow, that's my little rant on it, given a few seconds here. Thank you for your comment. Put some light on the usage of writing the automation scripts manually versus scriptless open source tools. Well, I got hit very hard this year with a scriptless open source tool that developed code that someone was using and thought was useful. The code was definitely interesting. The code was definitely useless from a testing perspective. The tool automatically generated the code based on a description of a contract without understanding anything about the business logic under test. I think these tools generate code that might be valuable if you are a really expert programmer, which is ironic because it's generating this code automatically. If you don't know enough about programming, you can't take that and abstract from it and do something useful with it. I prefer to make my little baby curl scripts, right? If that tool would say, here, Rob, is a little baby curl script that does what you wanted, I would take that and I would use that and I would build a library of those things. But these tools generate tons of ugly code that basically, it's obviously machine generated. It has no knowledge of your domain, and it basically doesn't do some of the fundamental things that I want to encourage people to do. I had one person have to totally redo all of their work by using automatically generated tools from open source things. I'm not saying these tools are bad. I just think you got to be a really good programmer to use the tool that is being advertised as something for people who don't have programming skills. This is ironic. The way to benefit from the tool is if you know programming, look at what it's got, grab the stuff you need, generalize, parameterize from a point of view that makes sense for your business, and use it. But if you're a non-programmer and you take that script, man, it's going to be very hard for you to reuse it outside of the context of the tool. So this scares me, and the tools that I was using and am using and am mucking with are very professional, and I've done commercial, non-commercial, some of the most popular ones in the world. I had, by the way, I had 150 students working with me on doing this over the last 3 months. I have a lot of real data, and it scares the heck out of me. Please, please, please be careful. Tread cautiously in the area of automatically generated code. And yeah, I know the tool is useful, but be careful. Can you elaborate about using JUnit to develop tests that are not unit tests? Elaborate? Sure. A JUnit is just a framework to run tests. The actual code in JUnit doesn't know what type of test it is. It doesn't know if it's a unit test or not. So the framework is very useful for writing programs that call things through APIs. And if I create what I call an integration test through an API or a series of APIs, JUnit is great to do that. I can find a nice example or two. I don't have them to share today, but I have basically, just to give you some context here, my McGill course finished a few days ago. I submitted the marks a couple of days ago, and I have my examples, but I haven't categorized them, and I usually will take 2 or 3 of them to share. And I have tons of examples of JUnit being used not for unit tests. I've got customers of mine all over the world that use just JUnit just as a test execution framework that doesn't care about the type or level of tests. Keep in mind terminologically, when I say unit tests, I mean tests created by developers to basically work on the chunks of code they're creating, and they're structural regression tests usually. So I'm not talking about the tool, I'm talking about the purpose of the test. Data migration testing. Okay. I have a lot of thoughts on data migration testing. Data migration testing is one of my favorite subjects, and it's often forgotten. So I'm so happy you brought it up. When doing data migration testing, I always have sort of old data and new data, and I use an analytic method called a come from analysis. And that, therefore, what I want to do is I want to say, where does the data come from and where it's going through? I create a model of that using a picture, a visualization that's a directed graph. It's just circles and arrows. And I draw this directed graph, what I call a come from analysis. So it's, what is the migration? Is it going from version A to version C, then from version C to D, then from D to W? So I want to follow the migration paths. And then once I've got those done, I use a tool called Paths. That the tool is PATHS, Paths, which is a tool that was created by some McGill students for me, and which I share for free with anybody who wants to have it. I do not publish this as an open source tool, but I share it with my students. If you want a copy of it, I'll throw one in with the stuff I share with Rahesh. And basically the path analysis then gives me what are the migration paths to try. Now the tool is helping me design my migration test. Now how I implement the migration tests, I can automate to some extent. It depends on the platform. It depends what tools I have. But even if I just have to do it by getting a group of people to do the migration mechanically, I don't mind. It's the path that's the problem. What is the migration path I want to test? And believe me, people have all sorts of bizarre migration paths. And so this tool helps me find a minimal set of paths to beat the crap out of the system and find great migration bugs. So that's the automation test design for migration analysis, data migration analysis. And of course, the specifics of it, I really believe you can use a lot of automation in that type of testing. And I believe also that you shouldn't try to generalize that, especially if you're doing migration across version. Every version is going to be different. So you want to do just enough automation to help you do example migrations. But think about this. Can you build a migration data set? I want to write some scripts to build the migration data sets and then put it through the migration and then do some analysis of the post. And so compare and contrast the beginning and the end. So one tool to design the paths, one tool to generate the data, and one tool to assess, hey, did I lose the data after the migration? I wish I had some picture to visualize that. It's a beautiful subject, a beautiful question. All I'm going to say about that.
Nice. Let me again check on YouTube or Facebook.
Really cool questions. Sorry if I'm going through them pretty fast. I just want to address them all a little bit.
Okay. Do we have any more questions here? Please post them in the questions tab. And meanwhile, Rob, I have a very unusual request for you. Uh, the first time we spoke, right? So you told about your overall programming and testing experience. And if I took the right notes, you started your like writing your first program maybe when you were 12 years old. Is
Yep.
that right? Okay. Uh, so the unusual request is if you can walk us through again through your experience, all these years on the things you have done. The reason being, even in today's time, when things are so fast paced, it gets very overwhelming when the tech stack change or when the market demand change, and
Yep.
the things like how do we cope up with the changing demands. That's really something which stays on every engineer's mind. And maybe if you share your experience through all these decades, that is something which may act as a big inspiration to people like us.
Okay. Well, it's a beautiful question, and it's the subject of my life. So I want to talk about one thing. If you want guidance from this, start with this notion. Keep this in mind. My ignorance is my superpower. All right? That's what I want you to keep in mind. My ignorance is my superpower. It's the fact that I know I'm not an expert and I don't know a lot of things. And what I've learned is how to learn. And that's what I started with, learning how to learn. I think that in my career, the technologies have changed dramatically. I wrote my first code on paper tape. Paper tape. And we would spend hours on stupid things like syntax errors, which today are gone. They don't exist today. The compiler does all that stuff. But we used to have to do that. And we would troubleshoot and debug by listening to acoustic modems.
Wow.
We're listening to them. If the pattern was wrong, there's a bug. Today, no one hears acoustic modems. Back then, it was very slow. We had, at that high speed for us was 110 baud. That was high speed. And the paper tape operators were big teletype machines, which went clunk, 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 clunk. And that was cool. So it's sort of awesome that the technologies have changed so much that today, we've got our cell phones that have more processing power than existed in the whole world. One cell phone has more processing power than existed in the whole world when I started. I mean, it's amazing. It's awesome. And the technologies haven't changed dramatically overnight. They've changed progressively. And yes, guess what? You and me are influencing this change, okay? It's not happening to us. We're making it happen. So be part of it. And as I evolved, I learned, and I never stopped learning. And I knew that I didn't want to get emotionally attached to a technology. And I was good at technology. I was a good programmer. Man, was I good. When I started commercial development, I kicked ass. I wrote device drivers and think of the time now. 1982 was the first commercial release I did, but I wrote that code before 1982. And it was a graphics library, which included libraries that did stuff with Windows and stuff with digitizers and all this stuff before Microsoft or Apple invented Windows. We did that type of crap. And we did it all at the API level, which was sort of beautiful stuff. But what did we learn? We learned our programming languages, our tools. And then to build an application, we started by building a test framework. We built a test framework. And then we adapted the test framework as more features were added and more features were added and more features were added. And the test framework changed. And in the end, the test framework became the application. And it was like, wow, you're saying you're not ending with a test framework. You're not building a test framework after you're finished. You're building the test framework to allow you to develop the application. And it's sort of, I always use the model of Michelangelo saying he would go and pick a big piece of marble And he looked at that marble and he said, aha, there's David. And he would sculpt away the statue, and eventually you have the statue of David from the marble. For me, that marble is the test harness. And you sculpt away until you get the application. It's a totally different way of thinking. I learned, of course, different technologies through the age. I started with a lot of work on proprietary ones from Digital Equipment Corporation. Then I got into Unix. I was a pioneer in Unix. I did device drivers, kernel code in early Unix distributions, which was given free to all the universities. So I was working with labs and universities, had all this great code. And of course, we had to build our own test harnesses, but not just test harnesses, debuggers and kernel debuggers. That's low level debuggers and microcode debuggers. Inside of the CPU, there's code running that we would have to write debuggers for. So we had to really understand the mechanics of the computer, and which was great because I learned about mechanics of computers. And I learned about that, and I found in my career, still to this day, I find great bugs because I have a strong knowledge of the mechanics of computing. I moved on technologically to CAD/CAM systems, graphics systems, and analytics software, even parallel processing in its early days, and that led me to learn how to build reusable libraries that are device independent. So we had like knowledge of concepts of device independence, and always when doing this, we're always sort of testing was always ahead of the curve. We never implemented something that we couldn't prove was okay. So we always sort of said, before we start writing the code, we got to make, how are we going to test this? And we didn't have to have the test script. We just had to have a method involved. Like, okay, we can prove this by that. And we used to use words like proof. Like we tried to have the rigor of mathematical proofs. And to the point that when I did some embedded software, we would take the actual compiled code and look at the binaries and make sure that the bytes changed in the code matched the bytes that should change, and the ones that didn't change matched the ones that shouldn't change. And we used in-place code patching techniques. This is stuff that today no tester would ever dream of. But basically, we got really intimate with the lowest levels of technology. That said, we didn't have to master it. We had to understand it. And not everybody's going to be the master, but understanding, moving from technology to technology, so jumping from processor to processor. My career evolved a lot. I worked in multilingual computing in that space. I got a lot of knowledge of the virtualization layers and how to decouple presentation layer from operating system layer, from business layer. All these things were layers. That's 87 to 97, that period of time. So it's not something that was invented 2 weeks ago by a DevOps person. You know, this is a modeling thing, and I learned how to make models and design models and use models to describe things. And also, I also learned that my models were always wrong. As the very famous statistician George Box says, all models are wrong, but some are useful. But I always said it's better to have a wrong model that people can talk about than to have no models. So part of my deliverables in testing, still to this day, is a visualization. When I was answering the question about migrations, the trick in migration testing is to draw the picture, right? Once you can visualize it, then you can talk about it, then you can identify risks, then you can test it. Anyway, I moved on to different sort of multilingual stuff, technologies, projects. Got into medical software for 3 years. In medical software, I was director of software engineering. I built some fantastic testing teams, had to work with doctors at the point of care doing diagnostic medicine. That software had to work or people could die. It changes your view of software testing. It was amazing how important it was that we could validate things. And I learned things like the notion of a conspicuous bug, where it was better to have the software fail conspicuously than for it not to fail. And this dispelled the whole notion of cosmetic bugs don't matter. That's bull. A cosmetic bug you might not even notice. It's much better to have a conspicuous bug that crashes with blue screens all over the place. And it's better for that failure to be so bad and devastating that the doctor who's using the software knows the software doesn't work and he uses another method to diagnose you. It's like if you had a blood pressure machine and the blood pressure machine explodes. Don't use the result of that machine. Go use another machine. Make sure the person knows if it's failing. Conspicuous failures was an impressive thing I learned in that period of time. And I also learned a lot about, iterative incremental methods and stuff like that. But all the time I'm moving technology. of adapting, learning new programming languages, learning things, and just learning enough to sort of be able to work in it, not to sort of say, I am the master of C++, but I learned C++. I am the master of Object Delphi. Well, I learned Object Delphi, but I wasn't a guru in it, but I learned it enough to be a little dangerous, I guess, but certainly enough to understand risks and maybe to benefit from it in some of my exploratory testing. And this has never stopped. So to this day, I'm always facing new projects, new technologies. I am not afraid of them. I trust that it's fun for me to learn them. I adapt. I just play. I have fun learning new technologies. But I also take advantage of the fact that I work as an adjunct professor at McGill for over 20 years. And that gives me a chance to experiment and work with some of the sharpest minds in the world of software development. Every kid, you got to realize that when I'm teaching a class there, every kid in the class, and then I say kid, they're young people, 20-ish years old. They're all superstar programmers. They're so good. They're so gifted. They're so sharp. And what I try to do is teach them the discipline of software engineering, the discipline of software testing, not the technical nuance of using tool A or tool B, but the discipline, and show them that, even from when they start to when they graduate, the technologies are going to be so different that it's much more important to build the skill to learn the new technology than it is to master any one technology. Is that what you were looking for?
Wow,
That's
yes,
right.
because I'm not sure why I'm getting my own echo. Yeah, now this is proper. Uh, because the transitions you have made, right, like or people who have been in tech for decades, that's something so amazing and so big to the temporary problems we look at currently, like the way, let's say, if the interest is shifting from Java to Python, people get worried. If it is shifting from Selenium to Cypress, people get worried.
Well, if you
And
invest a lot of money mastering Java, you're saying, am I losing that investment? Don't invest all your energy mastering the tool. Learn the models of the tool. Learn how to do something practical with the tool, but mostly learn how to learn new tools. I think it's just exciting. Python is so cool. It's fun. It's not just good, it's wonderful. And you just look at that example, that beautiful story I told you about the Seva search versus Google is awesome. And it's just so clean. I'll share the code. Like, it's so simple. And that's enabled by Python. So, and yet I'm never going to tell you, don't master Python. Learn enough about Python. Learn about the models of Python, but then get ready for the next one.
yeah,
It's
yeah.
cool.
Thank you. This helps. And we have two questions meanwhile. So Ajay asks, what is the secret of your energy?
The secret of my energy is my passion is just sharing and teaching and learning. I'm so passionate about it. I just love it. I love this field. I think it's beautiful. I think testing is one of the most important fields on the planet Earth right now. Do you realize that everybody who's listening to this right now knows at least one person whose life depends on software? And that if I asked you that question 5 years ago, it wouldn't be the same. Today, we trust software. People trust software. People implicitly trust software. And there's more risks than ever. There's millions and millions and millions of apps that people are trusting. We, as software testing professionals, are the voice of reason in that universe. We have really an important role to play to protect it. Software testing now is about social responsibility, and I'm proud of that. And I love it. I love it.
Yep, yep. And that's very evident. Your passion and love for the craft and what you do. Uh, we just hope that maybe just 1/10 of your energy, we can bring to our presentation, and when
Well,
we
you
represent
have
our
you have energy too, and the community that you've got here is wonderful. And I'm just so happy to be invited to share some ideas with you.
thank you,
If
Rob.
the
And
passion rubs off, that's good. But there's thousands of stories that build it, and every one of these questions could be a webinar by itself. I think there's two that slipped in. Do you want to try to answer them just while we're here?
yeah, so there is one by Nitin, like with so many automation tools are coming every now and then for API
Yeah.
and UI. how to focus on upskilling ourselves by not getting overwhelmed. So
Yeah. So first of all, throw the word upskilling out of your vocabulary. That's something for your HR department. For you, there's one skill, the learning skill. Learn how to learn, and try to separate the noise and confusion from what matters. And only you can learn what matters by looking at how people derive value from your work. So do value-driven testing, and that means purposeful testing. Being on time, on quality, on budget is meaningless unless you're on purpose. So I think that what you want to do is look at the technologies and the skills you need to apply those technologies, and find out which ones are valuable and which ones you want to enhance and encourage, and try to, what I call is orthogonalize, separate them a little bit, and don't make them attached to a certain technology. So learning about programming is about learning about modeling, and it doesn't mean learning a programming language. The programming languages will change, but the concepts of a lot of programming does not change. And so once you learn those models and those concepts, then you can migrate to new technologies. You call it upskilling because it's putting something on your resume that helps you get a new job, and that's important. I never want to make that trivial. If you need to have a skill on your list and you want to put it there, that's great. But being overwhelmed is not the issue here. Learn the tool, but learn how to learn tools is more important than mastering any one tool. So yeah, you have to put I know Python, but you might want to say, what can I do with Python? Not how well do I know Python? And that's value proposition. The guy's hiring you wants to see, oh, you can use Python and it can give you this value. Okay, that's interesting. It's not how many libraries do you know, because it is overwhelming. There's too much technical detail in any programming language. So mastering them is an overwhelming thing. And if you want to, you can try to do that. If that's your goal. But I would suggest the other way around is good. Does that make sense for the answer? I hope so. There's one more, I think, right?
yeah,
Okay. How do you see the role of the QA test manager? I love this type of question. I just, for fun, a couple of days ago, it was just for fun, I said, okay, what's this? What is a test manager? What is a QA manager? What's going on here? What do people call these things? Because if we were all using waterfall models with the same organizational framework, then probably we could define a generic role of what is a test manager. But today, with these weird models and varieties of agile frameworks and scalable agile and Kanban and Scrum and everything else in between, there's not an organizational framework for what is a manager, right? So I identified the titles. I looked at emails I'd received from people in testing world and posts I saw in places of LinkedIn just for the last few days. And I identified quickly well over 100 different titles for people who I think are in positions that are related to test management. And I said, this is an article waiting to be written. I've got to talk about the confusion of this stuff. So how do I see the role of the QA test manager? Man, I think that let's talk about your role as a human being. If you want to become a professional and you want to become someone who advocates quality and professionalism, and therefore you want that to rub off on people, that's more important than the role of organizational framework of a manager. I think that what you want to be is a mentor. You want to work with people. You want to share your experience, not as if it's prescriptive, but to show what you've learned from the past and to give people models that might give them a good starting point for the future. So I think that the role of QA mentors or senior people in QA or QA architect, whatever you want to call them, there's 50 names, 100 names, is basically to pass the torch in terms of value, to guide the values of the team. And I think that role will always exist no matter what your organizational framework is. It's not a hierarchical responsibility. It's a social responsibility. So I think that the test lead / manager as a mentor is good. I think in some organizations, it is very important that we have someone who takes on a organizational responsibility for testing. And if that's what your test manager is, make sure your method of testing and your method of development are synchronized. And to quote Gilbert and Sullivan, make sure that the punishment fits the crime, that the way you work helps solve the right problem. So I see that the test manager, therefore, in that context, becomes the marshal of that, becomes the sort of guide to make sure that people are following a work pattern that basically fits into whatever organization framework that is required or mandated. And this is especially important in regulated industries like medical software and defense software and financial software. So you have basically sometimes a role of test managers to marshal people. But primarily, I think, and this is the one that I love the most, I think that you want to also demonstrate excellence, not preach best practice, but demonstrate excellence, and teach people how to share examples. So be a as is in Plato. If you read the Republic from Plato, be the shadfly, be the fly that's bugging the horse. Right? Watch what's going on. Don't interfere so much with what's going on. Observe what's going on. Be a little bit intrusive, but learn and then share and encourage sharing between teams. So build libraries of examples, exemplars, and from those examples, build instruments of teaching, so that instead of saying this is the prescriptive way to do it, saying here's examples of what worked that didn't work. Let's discuss the context that made this work, so that we can maybe apply our learning in the future. I think those are the roles that I see as being pervasive in people in test management positions. End of
Wow.
rant.
We spoke about this, right? Like there are so many topics which I wish to hear from you more going ahead. And then like one of that was which you just spoke about few minutes back, learning how to learn. Or in our one of previous conversation, it was around learn how to learn a programming language rather than learning Java or learning something else, right?
You see my video?
Yeah.
Just want to show you, right? That's my library of software engineering books. I've got one of the biggest private libraries in Canada. And I never stop. I love reading about the field. One of my favorite learning tools is to read other people's
So if you see the smileys coming, like in this shape, right? So here in India, it is out of respect called Namaste. And it also like, so see what's going on if you see on the screen. So that's out of the respect for the knowledge you have, for the experience you have gathered through these decades. And we definitely look forward to host you again for we are already discussing a couple of topics, but there are so many other things which we can touch base again. And even the things which you covered in this webinar, I was just conducting a poll, and so many people said yes, they want a deeper look at these things, that how you are writing and using these small utilities and small snippets of code to do powerful things, and
that's
just
fun. Really fun.
Yeah. So like almost everyone, it was like 100% vote that okay, everyone wants to hear more on that as well. So we'll definitely keep on planning more things as and when it's possible to you. And yeah, let me just quickly see if anything in chat. Okay, so that's pretty much for today. But thanks again, Rob, for taking out time in your early morning routine and guiding the tribe and helping us know a lot of interesting things.
Well, thank you. I look forward to coming back and sharing, and I'll get you within the next day or so the link for all those examples so that you could share that with the community.
Sure, we'll do that. Thanks again, and have a nice day ahead.
Take care, everybody. Bye. Thank you.
Thank you, everyone, for joining on Saturday evening. See you again at the next event, and meanwhile, let's stay connected in